Good morning and welcome to Algebra 1 Honors. Today we're going to continue our discussion about functions with a couple of new pieces of information that will add to our expanding knowledge. Quick question. If I were to give you a graph that looks like this, first of all, is it a function? Hopefully by now we know that the answer is yes. Why is it a function? It passes the vertical line test. None of the inputs have more than one output. So a vertical line drawn on any one of those dots would only hit one of those dots, therefore, of course, it is a function. But now we have another bit of language. Now the question is it continuous or is it discrete? The answer is pretty simple, actually. A continuous function continues among every single point. So if that was a line all the way drawn through, you'd call it continuous because every value between the beginning and the end is a value on that function. But this is just dots. We call that discrete. Each individual dot shows you an input and an output for that function, but nothing exists that's not a dot. So this is a discrete function. An example of a continuous function would be perhaps what I'm drawing in blue right now. It's a function because it passes the vertical line test. Everywhere you would draw a vertical line, it will only touch that function once. But it's continuous in that their line is connecting. A line is just made up of an infinite number of points. So on every single value, to the smallest decimal, there exists a value that's on that function. So that is continuous. It's discrete if it starts and stops. Okay, little vocab for you. Now, let's talk about saying whether or not the function is increasing or decreasing and how we're going to name the places on which that occurs. So here is, let's say, I'm going to put a very simple x-axis. So from -4 to +4, and a very simple y-axis from -4 to +4. So there is my coordinate grid. Now I'm going to give you a function. It's not going to be a typical function. It's going to be a kind of a strange looking one. But we'll say that at -4, +3, it's got a dot, and it's going to continue in a, let's say, a decreasing way all the way down to -1, -1. It's not going to be a straight line necessarily, but it's continuing in a negative direction. Now, it's going to jump up to here. I'm going to use an open dot. Just like on our inequalities, because that's a closed dot, that means it exists when x is -1. The function exists down here, also at -1. But starting at -1 and going all the way to +2 on the x-axis, it's flat. And then at 2 on the x-axis, solid dot, and it's going to go up until we get to 4, 4, like that. Now, this is obviously not your typical graph. It's called a piecewise function. A piecewise function is basically chopped up into pieces, and we have to understand what's happening on each interval within the piecewise function. All this to say, all I want you to do right now is tell me where it's increasing and decreasing and remaining constant. So let's start with areas where our function is, well, you know what? It starts off with a decrease. Let's just talk about decreasing. It decreases from where to where? Well, how do we label it? It's all based on the input, the x value. So from an x value of blank to an x value of blank, it is decreasing. Well, what are those two numbers? it starts off right here, where x is -4. And it decreases all the way down to here when x is -1. And the dots are closed at both places, so it includes those values. So from an x value of -4 to an x value of -1, our function is decreasing. So we're going to say -4, comma, -1, first of all, because it's continuous. So at every point between -4 and -1 on the x-axis, our function is decreasing because it includes those endpoints with the closed dot. We use brackets around those values. Now please understand, that's not a coordinate. It's not the coordinate -4, -1, because that's a dot right there, and that's not even on my function. What it's telling you is that along the function from a domain value of -4 to a domain value of -1, our function is decreasing. Decreases along that interval. The next piece we have is flat. It's not rising, it's not falling. We call that constant. So our function is constant on that interval. Now, what are the x values we're looking at? Well, on this interval, from an x value of -1 to an x value of +2, it is constant. So we'll say -1 to +2. But we're not going to use brackets on this one. And the reason is, both of those dots are open. That means that it can't actually exist there. So we're going to use parentheses where it is open. I'm going to just make a little adjustment here because there's something I want to show you. The last little piece I had a closed dot. I'm going to leave it open. Now, it's constant on the interval from -1 to 2. Again, that is not a coordinate. We're talking about interval notation for areas of increase, decrease, or remaining constant. -1, 2 itself is a point, but that's not what we're saying. We're saying it's constant, flat, no change, on the x values of -1 up to +2. -1 to +2, flat piece of the function. And now it also increases after that. So we have an area of increase. Now, you can see the x value is 2 where the increase begins, and the x value is 4 where the increase ends. So it's from 2 to 4. When it begins, it's a filled in dot, and that means it's a bracket right here. Where it ends, actually it's an open dot, so I have to end it with a parenthesis. I know it looks weird. It looks weird to have a bracket and then a parenthesis as part of the same interval set, but that tells you that the values can and cannot be at those endpoints. So the value of 2 is definitely a place where it's starting to increase, but a value of 4, it doesn't exist there. That's what that tells you. Okay, that's a little bit about the notation, areas of increase and decrease, and the vocab words of continuous and discrete. Let's get to something a little bit easier to use and understand. I'm going to give you an equation. The equation we're going to use, y equals 2x minus 1. Now, this is something we're used to seeing. However, with functions, there's also function notation, which means there's another way of looking at the equation itself. We already know that a function takes an input and gives you an output. Function notation is this. You see f parentheses x equals 2x minus 1. Those are the same thing. F of x, that's how it's pronounced. F, which is the function's name, of, because it's in parentheses, x. What it tells you is when the function gets an input, x, it does this to it. It doubles it and then subtracts 1. The f doesn't have to be an f. It could be a g, an h, any other letter. It just stands for the function that we're discussing. All right. Those parentheses do not mean multiplication. Those parentheses are in function notation because they're preceded by the letter f. F is not a variable. F is saying, here's a function, it takes x as an input, and here's what it does with it. So, if we are going to then maybe answer some questions using this. Here's how the question would be asked now. What is f of 1? Now, it's telling you the input is 1, and you're going to use that information and plug it in to solve. So it's 2 times 1 minus 1. So f of 1 is 2 minus 1. So f of 1 equals 1. And that's the answer. And we want to see f of 1 equals 1. What it tells you is an input of 1 gets you an output of 1. Let's try another one. What is f of negative 3? All you're doing is you're plugging in the input and you're solving for it. So what's f of negative 3? Well, that's 2 times negative 3 minus 1. So f of negative 3 equals negative 6 minus 1. So f of negative 3 equals negative 7. Again, that's the answer. You're not dividing by negative 3. Don't do that. It's not a coefficient, and f is not a variable. It's function notation that tells you your input is negative 3, and then your output is negative 7. So the coordinate negative 3, negative 7 is a coordinate on our function. Let's try one that's a little bit backwards from that. We'll stick with f of x equals 2x minus 1. But this is also a way we could be asked a question. Now this does not say the same thing as the previous examples. This is not telling you what to plug in. This is actually telling you what the output will be. So the question is, what input will get the output to be 6? This time, you're taking the 2x minus 1 and you're setting it equal to 6. You see how it says f of x needs to be equal to 6? I'm going to replace the whole f of x with the number 6. The question is asked backwards from the previous ones. If the number's not in the parentheses, it's not the input. The question is, what input gets us an output of 6? And then I'm going to add 1 to both sides, and I'll divide by 2. So an input of 3.5 will get me an output of 6. 2 times 3.5 is 7, and 7 minus 1 is 6. So it could be asked in 2 different ways. You could be given the input f of 4, or you could be asked what input will get you an output, f of x equals 4. They're 2 different questions. You have to be able to understand the differences so that we can do both types of questions. Try another one here. I'll give you f of x equals half x plus 1, and I'll also give you a second function, g of x equals x squared minus 3. Now there's 2 functions. I'm going to give you, let's say, 4 questions, and that we'll call it a day after we go over them. So let's say f of 2, g of negative 1, f of x equals 3, g of x equals 6. Okay, so there's 4 questions here. 4 questions. Pause now, solve all 4 of them, and play the video. Pause now. So let's solve these. F of 2, well, that is going to be half of 2 plus 1, because it's the f function, plugging in the number 2. Half of 2 is 1, and 1 plus 1 is 2. G of negative 1, that means use the g function and plug in negative 1. Negative 1 squared minus 3. Negative 1 squared is 1, and 1 minus 3 is negative 2. F of x equals 3. So we're going to plug in 3 to the f function. So we have, f of x is 3. So 3 equals half x plus 1.
Mrs. Santos, can you please call extension 1523?
After the announcement goes by.
Melissa 1523.
Subtract 1 from both sides, we get 2 equals half x. Multiply by the denominator of 2, and you get x equals 4. An x value of 4 will get you an output of 3. So half of 4, what do we say, is 2? Yep, half of 4 is 2. And 2 plus 1 is 3, and that does work. Last one, g of x equals 6. So we'll say that 6 equals x squared minus 3. Going to add 3 to both sides. 9 equals x squared. I have to square root both sides to figure out this answer. Now, remember, I think I told you already, I might not have, that when you take the square root of a number, there's actually 2 solutions. Because the square root of 9 is 3, but it's also negative 3. There are 2 inputs that will make an output of 6. Because 3 squared is 9, and 9 minus 3 is 6, no problem. But negative 3 squared is also 9, and 9 minus 3 is still 6. So there's 2 solutions there. Okay, so attached to the announcement today is what's called a quiz prep worksheet, because basically, we're working our way down through the functions unit. And I want you to do the first 2 pages. It's a 3-page worksheet packet, with 3 sides anyway. And you're doing the first 2 sides. This is the homework due for tomorrow, and I need you to submit it for me also. Tomorrow is distance learning for all, because it's PSAT for 10th and 11th graders. And you guys are all going to be at home. There'll be a short video, and you'll be instructed on what work to do to continue our practice. That's all for today. Have a great day. Let me know if there's any questions or problems. Make sure you submit the homework by tomorrow morning. Thanks.